90% of all the data in the world was generated within the last 2 years. We are generating information at a velocity that physical infrastructure struggles to handle. The digital acceleration is actively overwhelming the conduits we build. Modern enterprises have to ingest and process an endless stream of inputs. That includes billions of IoT devices, robotic process automation bots, and increasingly complex digital supply chains. This graphic breaks down the projected scale of this digital ecosystem. You can see the top row highlights 75 billion connected IoT devices expected by 2025, alongside projections that 50% of organizations will have integrated RPA technology to interconnect their systems. Traditional enterprise systems cannot process this volume of information in real time. The architecture of those systems was built around a specific physical limitation, the mechanical spinning disk. SAP S/4HANA is a ground-up architectural rewrite. The software was redesigned to exploit modern hardware capabilities. Surviving this volume of data requires abandoning legacy database constraints and rethinking the hardware layer itself. For decades, the primary bottleneck in database architecture was the physical delay of reading and writing data to mechanical disks. While solid-state devices improved that speed, they still introduce latency. SSDs simply cannot compete with the sheer speed of raw memory. This diagram illustrates computing evolution, moving from legacy servers to powerful multi-core processors and huge memory. We can now store the entire database in memory, eliminating disk wait times. High-speed CPUs break apart complex analytical tasks, processing them in parallel for rapid response. SAP partnered with leading hardware designers, sharing product blueprints to ensure the new software was written to extract maximum power from these modern CPU architectures. By moving the database entirely into memory, physical hardware transitions from being an enterprise bottleneck into a real-time accelerator. Because of those historical hardware constraints, legacy IT architecture was forced into a compromise, splitting databases into 2 separate systems, OLTP and OLAP. Online transaction processing, or OLTP, is optimized purely for fast read and write actions at the record level. Online analytical processing, or OLAP, is built for batch loading, aggregated storage, and read-intensive queries. Look at the traditional approach. Moving data from OLTP to OLAP incurs massive latency, forcing users to wait for overnight batch jobs. The right side illustrates SAP HANA's HTAP approach. It processes both transactions and analysis instantly on a single platform. Transactional and analytical users can now work from the exact same single copy of live data with 0 delays. If data no longer needs to move between systems, the next logical question is how the database itself should be structured to maximize efficiency. Legacy systems required multiple separate data tables for different financial components, like FI, CO, and COPA, just to speed up slow queries through pre-aggregation. This chart visualizes how SAP HANA allows the application layer to delete unnecessary tables. The separate financial data streams combine into a unified sequence called the Universal Journal. Every posting now creates a line item directly in this one unified structure. This enables continuous accounting. Financial teams no longer have to wait for separate systems to reconcile at the end of the month. By deliberately shrinking the database footprint and deleting legacy tables, the S/4HANA data model becomes far more powerful, accurate, and easier to extend. This architecture graphic shows where S/4HANA sits within SAP's broader intelligent enterprise vision. It anchors the center business applications layer as the intelligence suite for the organization. Regardless of how an organization chooses to deploy S/4HANA, the data model, user experience, and underlying code line remain completely consistent. This table contrasts deployment options. For public cloud, notice the lowest TCO and quarterly innovation cycles for machine learning updates. Alternatively, private cloud and any-premise models allow for deep customization, customer-managed infrastructure, and strict regulatory compliance. This architectural consistency ensures IT leaders have the flexibility to match infrastructure to their exact corporate strategy without sacrificing the speed of the intelligent core. Physical hardware evolution mandated a complete software rewrite. By putting the database entirely in memory, SAP permanently eradicated disk latency. That lack of latency enabled HTAP, collapsing the decades-old divide between transaction and analysis processing. That convergence allowed the application layer to drop redundant tables, giving birth to the Universal Journal and real-time accounting. And this entire stack is engineered to be deployed consistently, whether in a public SaaS environment or a private data center. SAP S/4HANA provides the foundational, real-time architecture required to run a live enterprise in an era defined by overwhelming data.